Now, having introduced the numpy arrays, let's go one step further. This time we're going to talk about indexing, slicing, and filtering numpy arrays. We start with indexing. Indexing is simply to retrieve a value in an array by calling on its index. Again, we're going to always use square brackets to keep the index, right? One quick example, we start with the simplest thing, which is a one-dimensional numpy array. Right? This array is shown on the screen, but let's actually construct it in Python. First of all, we need to import numpy as np. Then we construct this one-dimensional array. Let's call it myArray, equal to np.array, and then a list of numbers 10, 11, 12, 13, 14, 15. And then we can let Jupyter display this array we will construct. So we have defined this one-dimensional array. Like lists, after we have defined an array, automatically every value is assigned an index. From left to right, index starts from 0. Right? Now, if we want to access one or several elements in an array, we can provide the indexes. Okay. Let's say the task here is to get the second and the fifth elements of the one-dimensional array we just created. The second element is element 1, index will be 1, right? Because everything starts from 0. And the fifth is item 4, index is 4, right? So 1 and 4 as the indexes. I'm gonna do my array, the name of the array, right? And then use square brackets. The indexes will be included in the square brackets. This time I want to get 2 items at the same time. So I need to provide a list of 2 indexes in order to retrieve the corresponding 2 values. Remember, if I want to get more than 1 items by indexes, we have to provide a list of indexes, right? So we have index 1 and index 4 between square brackets, right? We have double square brackets because when dealing with indexing, we need square brackets. And then when retrieving more than 1 values, we need to provide a list of indexes. Lists are defined by square brackets, right? So let's take a look. 11 and 14. And that's element with index 1 and element with index 4. Now let's look at a 2-dimensional array. The numbers going from left to right, top to bottom, we have from 10, 11, 12 until 18. First thing is to define the array. Let's do my array 2D because that's a 2-dimensional array, right? So we'll have 3 lists. From the first list is 10 to 12, and then 13, 14, 15, then 16, 17, 18. 3 lists, and then put those 3 lists between square brackets. So we have a list of 3 lists. And then apply np.array to convert the list of 3 lists into a 2-dimensional array. Let's also try to display the content of this 2-dimensional array. Right? The same thing as what we have seen on the previous screen. Now, let's say I want to get this number 12 by calling on its index. How can we do that? Well, this number 12 is in the first row and third column, right? So the row index, so let's first type the name of this array, and then square brackets for indexing. So the row index is 0. That's the first row. Everything starts from 0. And the column index of this number 12 is 2, 0, 1, 2. And that will help me get 12. If you want to get 15, then the row index is 1, right? The second row is row 1. And then the column index is still 2. You will get 15. If we can retrieve a certain value in an array, we can also change that value. Okay, so in this example, let's try to change the value at the intersection of first row and third column. Right, first row and third column, and that's 0 and 2 as the row and column indexes. Right, row 0, column 2, and let's try to do that. So my array 2D, let's say row 0, column 2, equal to the same entry right, multiplied by 2. Right? So it means that we first look at the right hand side of this equality of this assignment. We get row 0 and column 2 by indexing. We can get a value corresponding to this pair of indexes and multiply it by 2, right? And then I will assign the result back to this entry at row 0 and column 2, right? So let's then, after performing this calculation, we can again let Jupyter display the outcome, the content of this array, right? Now we can see that it's actually changed. All right, so that, I mean, if you look at the top right corner, it was 12, now it's 24. And then slicing. Slicing means that we want to extract a portion of the array. Like, you know, if we slice a pizza, we generally want to cut off a portion of the pizza. Again, let's start from a single dimensional array, construct the array. Let's again call it my array. And this time, what we want to do is from 10 to 15. To make it easier, I'm going to use np.arrange from 10 to 16, but 16 is not going to be included. So it's actually 10, 11, 12, 13, 14, 15, which is exactly the case, right? Now let's say I want to extract the portion starting from the second element all the way to the fourth element. So it's 11, 12, 13, right? What we can do is that we can do my array, the name of the array, and square brackets. We want to start from the second element index, which is 1, and 1, 2, 3, 4. Right, 1, 2, 4, that's going to be 11, 12, 13, but not including 14, right? The ending index is not going to be included. We're going to stop before reaching the ending index. And that exactly gives me a portion of the original array. So it's 11, 12, and 13. Of course, that's another array returned by this command. If we again do a slicing, let's say starting from element 1, it's actually the second element. If I don't specify the end index, let's see what happens. Basically, it goes from the value with index 1, the second value 11, right, all the way to the end. So if you omit the end index, it will go all the way to the end, and including the last value. Similarly, my array, I can skip the starting index. Right? Usually we'll write from some index to the to another index, a start and ending index. But if we can also omit the start index, instead, let's say I want to get until get up to index 4. Actually, we're gonna go all the way from the beginning to index 3, right? Because the ending index again is not included. This will give me 10 to 13. So it's going to be here 10, 11, 12, 13 from the beginning all the way to index 3, not including index 4. Right? So again, you can omit the starting index. That means you will start with the first element, index 0. Okay, so let's also try to do something about a two-dimensional array. And this time, again, the two-dimensional array is from 10 to 18. Construct this array again. My array 2D. Well, actually, we have another two-dimensional array constructed before, right? But now let's change the value. So it's 10, 12, 16, 17, 18, and then we make a list of lists. Then we do np.array, and that's gonna construct a two-dimensional array, right? Now I want to slice the first two rows, then the first two columns, right? Let's try to see. My array 2D, we do first two rows. So the row index will be 0 to 2, right? That's gonna be, index 0 and index 1, row 0 and row 1, 2 rows. And the columns, again, 0 to 2. See what we have, right? We turn out to get the upper left corner of the table structure, right? So basically we have selected the first two rows, and then from those two rows I'm gonna select the first two columns by dropping the last column. So we're gonna, from this two rows, I'm gonna select 10, 13 as the first column, 11, 14 as the second column. So that's slicing a two-dimensional array. A couple of more examples. Let's say this time I want to get all the rows. My array 2D. If I want to get all the rows, it's from beginning to end. If it's from beginning to end, I can actually omit both the starting and ending index, right? Not providing starting or ending index means that we start with the beginning and ending with the last element. And then for column, first and third column. So that's 0 and 2 as the indexes, but then I need to provide a list of indexes. So we need to use, again, the square brackets. Or we can do my array two-dimensional. This time, let's try to get the first and third rows while keeping all the columns. So the row indexes as a list will be 0 and 2, right? That's the first and third rows, because again, indexes start from 0. And all columns, just to provide a column without the beginning or ending index, mean that I want to get everything. Okay, so that's how we do slicing. One interesting thing is to do some filtering. Similar to slicing, we're going to choose elements, a portion of the elements in the original array. But often case, this is more practical, right? Because you don't always know which value is stored at what position. Instead, often we want to select elements based on a certain condition. Now let's say I want to construct a one-dimensional array, gas prices. And let's say we have 5 different gas stations. Each lists a different gas price. Let's just do any random numbers. Okay, 120, 140, 125, 155, and 137, and finally 161. That's a list. Let's make it an array. and let's display it. Okay, a list of 5 numbers representing gas prices at 5 different locations. Now, we want to select some of those prices. This time, let's try to provide a condition. Let's say I want to get all the prices above 140, right? So what we can do is that I'm going to write the name of this array, and then let's write a condition. The gas prices above 140, right? That's a condition to check if some of those prices will be more expensive than 140. And then let's see what happens, right? So basically it's a list of an array of 5 Boolean values: false, false, true, false, true, right? It means that the first number does not satisfy the condition. So the condition is false for the first number. And second number, again, is false, but the third number is greater than 140, so that's true. 137, the fourth number is below 140, so false. Finally, 161, the last number is greater than 140, so it's true. Right? If we write a condition, then Python will check if this condition is satisfied by every single entry of the array. Okay, so in order to select elements, we can do the name of the array, gas prices, and then square brackets. Inside the square brackets, let's provide a condition. Right? This time, if I include the condition between the square brackets following the name of the array, we will be able to get those elements that satisfy the condition. Let's see. Right? So what we get here is 155 and 161, and those are the 2 prices that are above 140. Right? That's how we select elements based on a condition instead of based on indexing. We can also do multiple conditions, right? One example, let me just copy the previous statement and then modify it. Okay, so this time let's include 2 conditions. The first condition, let's say gas price greater than 150. When you have several conditions, we want to put each condition into a pair of parentheses, right? And I want to select gas prices based on this condition and another condition. Let's use an and symbol to join 2 conditions, meaning that I have to satisfy both conditions at the same time, right? So gas prices greater than 150 but smaller than 160. Okay, so that should be able to get me the gas prices between 150 and 160. And let's see what we get. So it's 155. That seems to be the only value between 150 and 160. Right? Or we can, instead of joining 2 conditions, we can use the or condition. Replace the and symbol with or symbol. This time, let's say either greater than 160 or smaller than 130. Let's see what happens. This vertical line represents this, using an or condition, right? Either condition is satisfied will be okay. So either above 160 or below 130, right? That the only thing that satisfies one of the conditions will be 125 or 161. Right? Just a couple of more examples. Let's say this time I want to get a condition, gas prices. The condition will be gas prices not equal to 125. Exclamation mark followed by equal, that means not equal. The single price 125 was removed. That's because I only want to get the prices not equal to 125, right? And sometimes we want to choose a gas price exactly equal to something, right? So let's again copy the previous code, and then this time let's say I want to only get the price equal to 125, and that's just 125, right? Pay attention here. If we do assignment, we use one single equality mark. However, if we want to provide a condition to check if something is equal to something else, we have to use two equality marks. We can also use conditions to compare two arrays. Here, let me again quickly go back. I want to copy this line of code, and that's it's again an array, right? But this time I'm gonna call this array morning prices, gas prices morning, right? And then I want to also do another array, gas price afternoon, right? Let's change a few values. 140, let's say went up 145, and the second value, let's say the same. The third value becomes 150. The fourth value becomes 139, and the last number being the same. Now what we want to do is that let's write a condition. I want to see if morning prices are equal to afternoon prices, right? This is the condition. And then we run this condition, we'll see that, okay, for the second element and the last element, it's true, right? So let's make it a bit more aligned to see better. The only two prices that has not changed are 125, the second price, and 161, the last price. Then I can select from the morning prices based on this condition. So morning prices followed by the square brackets. This means that from the morning prices, I am only going to select the prices that has not changed. Okay, let's see if we get the results. So the result will be 125 and 161, which are exactly the only two prices that did not change going from morning to afternoon. So that's one thing very important, filtering. A couple of more tricks around numpy arrays. One thing convenient is use the zeros command. So np.zeros. Let's say I use the number 5. That will give me an array of 5 numbers, right? Or I can do np.zeros. Let's say 5 and 2. So that means I will get an array of zeros. But this time I will have a two-dimensional structure. The first dimension be 5, so we have 5 rows. And the second dimension is 2, we have 2 columns. An error. I think I should provide those two numbers between a pair of square brackets. Right? That's the format of np.zeros. Okay, so now another trick often useful is called reshaping. To quickly get started, let's create an array. So let's say again my array equal to np.array, maybe np.range, which is more convenient, from 0 to 10. And that will give me an array from 0 to 9, right? 10 elements in total. Now this is a single dimension array, so it's like a row of numbers. But if we want, we can change the shape. Let's say np.array reshape. I want to reshape into a structure. Let's say 5 rows and 2 columns. Right? Again, 10 elements, 5 rows and 2 columns, and we will have this one, right? Know that when we take the elements in the original array, so basically we start from the first number and going from left to right, and then for the new array we want to generate, we start to populate the new array starting from the first element and going right on the same row. Once a certain row is filled, because we can only have 2 columns for every row, right? And then I move on to a new row, following the original sequence of numbers. In this example, what we have done is that we had to specify, the shape 5 times 2, 5 by 2, right, as the new shape of the data structure. But sometimes, let's say I just want to say I want to reshape my array. I know that I want to reshape it into a structure that has 5 rows, right? I mean, if it has 5 rows, 10 elements, we have to have 2 columns, right? But then sometimes I just don't want to calculate how many columns should I have. So it's 5 minus 1 as a placeholder, right? I know that I want to have 5 rows, but how many columns? Let Python calculate it. So I will have exactly the same result, right? Or you can do 2 rows, but how many columns in a row? Let Python deal with it. I don't want to calculate it. And then Python will take care of the rest. Okay, so another useful trick. So my array is currently a row, right? What if I want to reshape it into a column? Well, in that case, I know that after reshaping, we want to have 1 column. So comma, following comma have 1. That means that the column, I only want to have the column shape being one column, right? And then I don't want to calculate how many rows do I need to specify. Instead, just use the placeholder -1. Then it will simply help you calculate how many rows you need to have in order to change the original array into the shape of 1 column, right? Sometimes it's going to be very convenient if you just want to quickly, say, reshape a row into a column. And that's, well, not really have a deep meaning for now, but later on, as we will see, sometimes it's really convenient to quickly change a row into a column for certain type of algorithms.